Okay, so we're here talking about energy pie charts today. So the first thing we want to do is draw our interaction diagram because that just helps us think about what's in the system. So in this case, on this whole worksheet, this is energy pie charts practice one. It's all the same system. It's all this little wind up bunny. So we only have to draw this interaction diagram once. And so with the interaction diagram, I'm just writing what's in the system and what's connected to it, just again to help me think through what types of energy might be at play here. So I've got the bunny. I'm just going to circle it. Any object, circle it. Now I think what's interacting with the bunny, like what's pushing the bunny, pulling the bunny, anything like that. Well, it's got its little winder on its back, and that seems kind of important. So I'm actually going to separate out the winder. And then I just draw a little line between them to show that they're connected, they're interacting. And it's not floating in space. He's on Earth. So the Earth is interacting with the bunny, but also the bunny is interacting with the ground, like he's sitting on the ground or the table or whatever he's on. So I'm going to add that as a separate thing because that's different than the Earth. And so when I look at that interaction diagram, I'm just going to kind of think about the types of energy that I might have at work in any of these problems. I'm just going to write them off to the side. So that little windy thing, remember, that's a stretch. That's like winding a spring in there. That's elastic energy. The bunny might be moving, so that would be kinetic energy. If the Earth is pulling on him, that's gravitational, positional energy. And then finally, if he's moving on the ground, there might be some friction there. So that would be thermal energy. So that doesn't mean that all four of these energies are going to be in all of my pie charts. They're just kind of the ones I'm choosing from. So if I need any energies, that's like my bank of energies I'm going to choose from. All right, so right now, a wind-up toy is fully wound and at rest. So he's fully wound. That means he has a lot of elastic energy. So I know for sure I've got elastic energy. He's at rest, no kinetic. He's sitting just on flat ground. He's not on a hill, he's not up high. So no gravitational. And he's not moving, so there's not going to be any friction, so no thermal. So this one's really easy. It's just all elastic. The only type of energy this bunny has right now is elastic energy because he's all wound up, but he hasn't gone anywhere yet. So see how we kind of went through that checklist. Okay, so let's go to the next one, keeping that checklist in mind. I'm not going to draw the interaction diagram because it's the same. All right, so here I've got the toy is wound up, so I'm going to write myself a little note. That's elastic energy. He's moving at a constant speed. That's going to be kinetic energy. And up an incline, that means gravitational energy. So keep that in mind. Now, I like to focus on one type of energy at a time. So I'm going to focus on the kinetic because that's the easiest one. It says moving at a constant speed. That means the kinetic energy is going to be the same throughout the whole pie chart. So I'm just going to make like a quarter of the pie chart. That's not a really very good quarter. I'm going to make a quarter of the pie chart, EK, but hopefully your quarter will look a little better than my quarter. So close enough to a quarter, right? Imagine that we're cutting pieces of a pie or cutting pieces of pizza. So they always should kind of go through the middle, and those are roughly the same size. So that's my EK. I'm actually going to zoom in a little bit on my page here. And that might help me get better quarters. So my pen's a little fat. So let's try that again. Ignore those little L's at the top there. All right. So I'm making the same size slice of EK. EK, because it's constant speed. So constant speed, same kinetic energy. Constant speed, same kinetic energy. All right. Now, we either need to pick E elastic or E gravitational to do next. It doesn't really matter. I'm going to pick E gravitational. He's going up the hill. So that means my E gravitational pie slice must be getting bigger every time because he's going up the hill. So I'm getting more gravitational energy. So my EG slice is getting bigger. I'm getting a bigger piece of the pie every time. I have more gravitational energy as I get more height. Now, lastly, we kind of have this mystery slice left here. Like, what's this left? We know the total energy has to be 100%. It doesn't change. So we can't leave that blank. There's some mystery energy here. Well, what's driving the bunny up the hill? It's the winder, the elastic. So that little mystery piece of energy is actually the elastic energy. And notice that the elastic energy is decreasing. And that makes sense because the toy is coming unwound. So as the toy unwinds, the elastic energy decreases. You don't have that stretch inside there anymore. So the total energy stays the same, but it just transforms to different types. Okay, we're going to do one more here. So the toy is wound up, elastic, moving, kinetic, at a constant speed. So our kinetic is going to be the same the whole time. So again, I don't know, let's make this quarter kinetic. It doesn't have to be a quarter. It could be half kinetic if you want, but it just seems easy enough. So I'm going to make it a quarter kinetic. It stays the same. It's a constant speed. EK, EK. Okay. So then it's a wind-up toy, right? We know it has elastic energy. But what happens to its elastic energy as it keeps going and going and going? Well, its elastic energy is going to decrease. So maybe it starts at this is all elastic energy. This whole big slice. But then now we have less. And then now we have a little less. And now we have a little less. And even less at the end. So that elastic energy slice, it gets smaller and smaller and smaller. So where's that energy going? Because it's not climbing a hill, so it's not going into gravitational, but it's also not disappearing. So whenever it looks like you're running out of energy or energy is disappearing, that's always thermal. It's going to the friction. So it's going to thermal, friction. So that elastic energy, instead of turning into more kinetic energy, it's actually turning into thermal energy for friction. So in that case, we still have three types of energy, but we don't have that gravitational because it's not climbing up the hill. So I'm going to let you do this last one on your own, but just to give you a few hints, it's wound up. That's elastic. It's speeding up. That's kinetic. And let's do this too. Elastic, if it's moving and it was wound up, that elastic energy is going to decrease. If it's speeding up, the kinetic energy is going to increase, and it's moving up an incline, that means your gravitational energy has to increase too. So as you go across, your elastic energy should get smaller, but your kinetic and gravitational should get bigger. So good luck.